And welcome again to our college algebra section. This time we're going to be talking about section P5, algebraic expressions. Although this section might as well be called polynomial expressions because that's where we'll be spending most of our time. Most of the slides we're going to be looking at are just going to be dealing with terminology. We will do some exercises. Honestly, I don't think you'll find the exercises that challenging for this section. P2, P3, and P4 generally present much more of a struggle for my students than P5. I think that's mainly because this kind of material you really experience as soon as you start algebra in any form, so whether that's in middle school or high school or wherever. So terminology. A variable is just a letter. Some people joke about mathematicians that our alphabet only contains the letter X, but of course you can use a variable to represent any number. In equations it often represents an unknown number that could be any number in a given set. Such like when I'm solving that equation and I don't know what X is, I assume X is a real number, and I solve it to find out what it is. Obviously it would be 2 in that case. But we also use variables just as general elements of a set. Like in P2 when we were talking about the commutativity of real numbers, we let A and B be any real numbers and then said A plus B equals B plus A. So we often use them in conditions or theorems to show certain things about any elements in a set. Once you have variables, you take variables and you combine them with numbers through operations like addition, subtraction, multiplication, division, and through relations like equals and less than and greater than and less than or equal. And you make algebraic expressions like equations or just that's an algebraic expression, 3x plus 1. An equation, you could say, is just one algebraic expression equals another algebraic expression. And you could even call the entire thing an algebraic expression. An expression in mathematics is kind of like a sentence in language. It describes an idea for you. We're going to talk about a specific type of expression. And that type of expression is polynomials. But first, we're going to build up polynomials by talking about monomials. So here's the definition for a monomial in X. It could be in any variable. I just, for simplicity's sake, chose it to be a monomial in X. A monomial is an algebraic expression you can write in this form, ax to the n. The important parts, a is a real number, that's not very restrictive, but n has to be a non-negative integer. So these are all monomials. Negative square root of 2 is a real number, it's just an irrational number. 1/3 is a real number, 5 is a real number, 2 is a real number. And each of these have an exponent that is an integer, and that is non-negative. This one shows you that it doesn't have to be a monomial just in X, it could be a monomial in Y, or in several variables. To be a monomial, it just has to be a multiplication of a real number and some variables raised to an exponent. You might be curious about this monomial. How does it fit these characteristics since it doesn't have an X? Well, I could write it in a form that has an X, though. Because, see here, 2x to the 0, if you remember from P3, x to the 0 would just be 1. 2 times 1 is 2. So yes, even a constant number would count as a monomial. Down here we gave some examples of expressions that would not be monomials. This one, because the exponent is not an integer, This one, because the exponent is not a non-negative integer. It's a negative integer, so it can't be non-negative. By the way, if you would like to know the name for something like this when it's not a monomial, the more general word we use to describe just a multiplication of a number and a variable or set of variables raised to powers is as algebraic terms. So these two expressions would both be considered algebraic terms, even though they're not monomials. And in fact, all monomials are algebraic terms as well. We'll use that word throughout the semester. Moving on, the degree of a monomial, you just find its power on the variable, or sum of powers if you have multiple variables. So here's the examples from the previous slide. If you look at this monomial, you see its exponent is 6. That's the degree of the monomial. If you look at this monomial, you see its exponent is 51. That's its degree. This one we saw before, the exponent on its variable would have been 0. This is a 0th degree monomial. And this one, you have to add 17 plus 4 plus 1 is 22. So this is a 22nd degree monomial. From monomials, we build the larger class, polynomials. A polynomial is any sum of monomials. So a monomial would technically be a polynomial. It's just the sum of one term, so it's not that exciting. But any sum, so here you have 3 monomials added together, that's a polynomial. One term, you see these things are separated by commas, that would be a monomial. This is 4 terms. They're all polynomials. Monomial is just a special class. It has one term, just using the prefix there. Mono means 1. Bi means 2, so a polynomial with 2 terms is sometimes called a binomial. I don't actually have one there, but it wouldn't be difficult to create one. Here would be a binomial. Don't really need that parenthesis. There's a polynomial with 2 terms, so you might call that one a binomial. This first polynomial had 3 terms, you could call that a trinomial. You could keep attaching prefixes, but beyond trinomials, usually they just call them multi-term polynomials. So you might say it's a 4-term polynomial, or a 5-term polynomial, etc. The degree of the polynomial is the largest non-zero monomial degree. So let's go back and look at our polynomials. The largest non-zero degree would be 6 in this first polynomial, so that's a 6-degree polynomial. The largest, of course, that's a 51st degree polynomial, because that's the only degree there. This third polynomial looks like the degree would be 4. That's the largest monomial degree. And this last polynomial down here, you might say it'd be 31, but that is a 0 monomial. It really doesn't have a degree of 31 because it's just 0. 0 has no effect because, 0x equals 0x squared equals 0x to the 4th. They're all 0. If 0 was any degree, you'd almost say it would be a 0th degree. But the degree of this polynomial would be 22 because that's the largest. Then we talk about leading terms. The leading term of a polynomial is the monomial that contains the degree. This is the leading term, 3x to the 6th in the first one. This is the leading term because it's the only term. This is the leading term in the third polynomial, negative 0.001x to the 4th. So in a problem in the homework, if they asked you to find the leading term, don't forget to write the sign as well. Negative 0.001x to the 4th. And in the third polynomial, of course, the leading term is 8x to the 7th y to the 15th. The leading coefficient. The coefficient of an algebraic term is just the number in the front. So this term, its coefficient is 3. This term's coefficient is negative 5. This term's coefficient is 2. This term's coefficient is 1/3. this term's coefficient is 7, this term's coefficient is negative 0.001, etc. So the leading coefficient is the coefficient of the leading term. So the leading coefficient of this first polynomial is 3. The leading coefficient of this third polynomial is negative 0.001, and the leading coefficient of this fourth polynomial is 8. That's actually going to finish off all the theory we're going to do in this section. All we have left to do now is exercises, and what we're mainly going to do in the exercises is do arithmetic with polynomials. Now that we've introduced these new objects, we're going to do addition, subtraction, and multiplication with them. We will eventually do division with polynomials, but that's a much more complicated operation, and we're going to save it for when we need it in Chapter 3. I will see you in the next video when we do some exercises from P5. I think we'll probably just end up on 2 videos for this section. I don't anticipate spending a lot of time on the exercises, although we will spend some. I'll talk to you then.